Welcome to section 1.2, the graph of a function. Objective 1, identify the graph of a function. When a function is defined by an equation in x and y, the graph of the function is the graph of the equation, that is, it is the set of points x, y in the xy plane that satisfy the equation. Not every collection of points in the xy plane represents the graph of a function. Remember, for a function, each number x in the domain has exactly one image y in the range. This means that the graph of a function cannot contain two points with the same x-coordinate and different y-coordinates. So to help us determine whether a graph is a function, we can use the vertical line test. Okay. Now, the vertical line tests that a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. So if we are given graphs, as you see here in our example, and we are told to determine whether the graph is a function, we can use the vertical line test. So we will be drawing vertical lines through the graph. The goal is to try and find a vertical line that touches the graph at more than one point. If that vertical line cannot be found, then we can say that the graph represents a function. So in the first one, A, we have the graph of y equals x squared plus 1. If I were to draw vertical lines through the graph, you would see that all of the vertical lines only touch the graph one time. Okay? Therefore, this is a graph of a function. So yes, it is a function. All right, B. We have the graph of the quantity x plus 1 cubed. So let's draw some vertical lines. Let's try and find vertical lines that touch the graph at more than one point. I'm unable to find those vertical lines. Therefore, this is also a function. Okay, C, we have the graph of x equals y squared minus 3. So I'm going to draw vertical lines. Oh, this vertical line touches the graph at 2 points. Oh, this vertical line does as well. So this would not be considered a function. And D, we have the graph of x squared minus y squared equals 1. I can identify vertical lines here that touch the graph at more than one point. So this also is not a function. So if you're given a graph and told to determine whether that graph is a function, identify your vertical lines, visually represent a vertical line through the graph, and if the vertical line touches the graph at more than one point, it's not a function. Objective 2, obtain information from or about the graph of a function. So if the point xy is a point on the graph of a function f, then y is the value of f at x. That is, y equals f of x. Also, if y equals f of x, then the point xy is a point on the graph of f. For example, if the point -1, 3 is on the graph of f, then f of -1 equals 3. And if f of 4 equals 7, then the point 4, 7 is on the graph of y equals f of x. So taking that, let's walk through this problem together. So we're going to let f be the function whose graph is shown here on the right. What are f of 0, f of pi over 4, and f of 7 pi over 4? So all of the values that we are using to evaluate f with are our x values. So we want to now find what f of these x values equals. In other words, we want to find the y coordinate. So f of 0 means I'm going to go on the x-axis and go find the point on my graph that has the x-coordinate 0, which is this one right here. So I know f of 0 equals 0. Now let's find f of pi over 4. I'm going to go on my x-axis and I'm going to find the point. Well, I'll find pi over 4 first. And then I'm going to find the point that has the x-coordinate, pi over 4, and then identify the y-coordinates. So pi over 4 is right here. So this would be my point. Therefore, f of pi over 4 equals 2. Now we need to find f of 7 pi over 4. So 7 pi over 4 is right here. So our point is right here, which means f of 7 pi over 4 equals -2. Okay? So what is the domain of f? So for this graph, the domain is going to be all of the x values are represented in our graph. Well, the lowest x value that's represented is 0, and the highest x value is 2 pi. So our domain goes from 0 to 2 pi. Now we actually have points at these x values, or points that contain these x values. Therefore, we have brackets on this interval. Okay? Now let's identify the range. So these are the y values. Well, the lowest y value that is present in our graph is going to be -2. All right, these 2 points right here both have y coordinates of -2. The highest is going to be 2, which are these 2 points at the top. Now there are points that contain these y coordinates. Therefore, we have brackets on this interval as well. All right. D, list the intercepts. Now the intercepts are where the graph crosses the axes. So the x-intercepts would be where the graph crosses the x-axis, and the y-intercepts would be where the graph crosses the y-axis. Okay? So to list all of the x-intercepts, let's first start off with the x-intercepts. So where the graph crosses the x-axis, right, would be here, 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 and here. So those x values would be all of the zeros of our function. So those would be the points 0, 0, pi over 2, 0, pi 0, 3 pi over 2, and 2 pi. Those are all of the x-intercepts. Now the y-intercepts. Well, the only point that I see on the y-axis is the point 0, 0. So 0, 0 is going to represent an x-intercept and a y-intercept. So we have all of our intercepts for our function. All right. How often does the line y equals -1 intersect the graph? So y equals -1 is a horizontal line. So y equals -1 would be this line right here. Okay? That's y equals -1. Now, how many times does this line intersect the graph? Well, it intersects it right here, right here, right here, and right here. So that would be 4 times. It intersects the graph 4 times. All right. F. For what value of x does f of x equal -2? Okay, so we're saying with this problem is that we're trying to find an x coordinate because it said what value of x. Okay, so we're trying to find an x coordinate. Does f of x equal -2? Well, f of x is the function notation for y. So this is the same thing as y equals -2. So then this question rephrased is saying, what is the x coordinate whose y coordinate is -2? Okay, well, let's go to y equals -2 and see if we have any points that contain the y coordinate -2. Well, looking at y equals -2, I see 2 points. So what values of x does f of x equal -2? Well, x can equal 3 pi over 4, or x can equal 7 pi over 4. Both of these x values will get you an f of x that is equal to -2. All right, now G. For what values of x is f of x greater than 0? So f of x being greater than 0 means f of x is positive. All right, so all numbers that are larger than 0. Okay, so we're trying to find the interval notation where f of x is greater than 0, or where all of the y values are greater than 0. Okay, so the interval notation for that would be this part of the graph. And let me highlight for you. Let's use a different color so that you can see. Okay. So all of the values of x where f of x is greater than 0. Okay, so it would be the top portion of our graph. This would be where all of the y values are greater than 0. So the x coordinates for that would be from 0 to pi over 2. And we have parentheses at these coordinates because the y coordinates at 0 and pi over 2 is 0. And we want greater than 0. So we can't put brackets on that. And union pi to 3 pi over 2. Okay, so those two would be the ordered pairs, or sorry, not ordered pairs, the intervals for where f of x is greater than 0. The real zero of a function. If f of r equals 0 for a real number r, then r is called a real zero of f. If r is a real zero of f, then the point r0 is on the graph of f. So the x-intercepts of the graph of a function are also the zeros of the function. Okay? So to find the zeros of the function f, whose graph is shown above, and I brought it down here for us to look at. So the x-intercepts are also the zeros. So since we already know the x-intercepts, we can state that the zeros are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi, because those are the x-coordinates of the x-intercepts. Okay. Now consider the function f of x equals x plus 3 divided by x plus 4 and answer the following questions. A is first asking us to find the domain of f. Okay, so f of x is a rational function because it's a ratio. Now, the domain is going to be all real numbers except for where it's undefined. And in order for this ratio to be undefined, the denominator must not equal 0. Okay, so we need to determine what values of x make the denominator 0. So we'll set x plus 4, which is the denominator, to 0, and solve for x. So x equals -4. So that means the value -4 will make our denominator 0, therefore making our function undefined. So the domain in set notation will be all of the x values except for when x equals -4. In interval notation, it'll be from -infinity to -4 union -4 to infinity. And that would be the domain of f. Now B is asking, is the point 1 3/4 on the graph of f? Well, to determine whether this point is on the graph, we need to evaluate our function at a specific x. So the x coordinate here is 1. So we're going to let x equal 1. And we're going to now evaluate f at 1. If this point is on the graph, then when we evaluate f at 1, we should get 3/4 as our answer. If we do not get 3/4, then we know that the point 1 3/4 is not on the graph of f. So let's evaluate it. So we're going to substitute in 1 for x. So we have 1 plus 3 in the numerator and 1 plus 4 in the denominator. So that's 4/5 as our answer. 4/5 is not equal to 3/4. Therefore, the point 1 3/4 is not on the graph of f. Okay? Awesome. So if x equals 2, what is f of x? What is the point on the graph of f? So we know that x equals 2, so we can identify f of x, or in other words, y, by substituting 2 in for x. So we want to find f of 2. So substituting 2 into our function, we'll have 2 plus 3 in the numerator and 2 plus 4 in the denominator. Simplifying, we get 5/6. Okay? So this would be the value of f of x. So f of 2 equals 5/6. And the point on the graph would be the ordered pair 2, 5/6. Okay? Now D, if f of x equals 4, what is x? What point is on the graph of f? So now in this case, f of x equals 4 versus in C, it gave us x. So now we're going to set the function equal to 4 and we're now going to solve for x. So f of x equals x plus 3 divided by x plus 4, and we're now setting that equal to 4. So now we want to solve for 4. Okay? So we're going to multiply both sides by x plus 4, which will eliminate the x plus 4 in the denominator on the left-hand side. Okay? We're going to distribute the 4. So we have x plus 3 equals 4x plus 16. Okay? Then we're going to combine like terms, right? So I am going to move all the x's to one side, all the terms with x, to one side, and then move all the constants to the other side. Okay, so I'll have 3x equals -13. And then I'm going to divide both sides by 3. And I'll get -13/3. Okay? So x equals -13/3, which gives us the ordered pair -13/3, comma 4. Alrighty. E. What are the x-intercepts of the graph of f, if any? And what corresponding points are on the graph of f? Well, we know the x-intercepts are also the zeros of the function. So we need to determine what are the zeros of the function? What values of x will make f of x equal 0? So we're going to set f of x equal to 0. So x plus 3 divided by x plus 4 equals 0. And then we're going to solve for x. Okay. So we'll multiply again both sides by x plus 4, which will eliminate the x plus 4 in the denominator on the left-hand side, which will just give us x plus 3 equals 0. Then we can solve for x, and x equals negative 3. Okay. So x equals negative 3 is an x-intercept, and its corresponding point is going to be negative 3, 0. All right. Then what are the zeros of f, if any? Well, if negative 3, 0 is the x-intercept, then negative 3 is the 0 of f. Okay, awesome. All right, now let's apply a little bit of what we've been working with to an application problem. So a plane crosses the Atlantic Ocean 3,000 miles with an airspeed of 500 miles per hour. The cost in dollars per passenger is given by the following equation. C of x equals 150 plus x divided by 8 plus 38,000 divided by x, where x is the ground speed. So that's the airspeed plus or minus the wind. Okay. A first tells us or asks us, what is the cost when the ground speed is 470 miles per hour? Okay. Well, we know for our unknowns that C in dollars is the cost in dollars per passenger. So that's what C of x equals, the cost per passenger in dollars. And x is the ground speed. Well, our question is asking us to find the cost. That means it's asking us to find C of x, which means we're going to need to have x, because in order to find one variable, all the other variables have to be given to us. So it tells us that the ground speed is 470 miles, so that's x. So evaluating C of x when x is 740, we can substitute in the value 470 for x to get our answer. Okay? And so let's plug that into our calculator. All right, so here's our calculator. So I have 150 plus the ratio 470 divided by 8 plus 3. Let's do the ratio first. 38000 divided by 470. And I get a ratio in my calculator, but I want it as a decimal. So I'm going to press math, and I'm going to go down to number 2 decimal so that it can take my previous answer and convert it to a decimal. And so I have this decimal, and I know I'm working with cost. And so when I'm working with money, dollars, I'm going to round to the second decimal place. So this would be $289.60. Right? This will equal $289.60. That would be the cost when the ground speed is 470 miles per hour. Now find the domain of C. Okay. Well, in looking at our equation, I see 150, I see a fraction x over 8, and then I see another fraction 38,000 over x. Now, between all of these different terms, only one of them I know for sure has a restriction, and that's going to be the 38,000 divided by x. Why? Because x is in the denominator, and in order for that ratio to be defined, x cannot equal 0, right? So that means for my whole equation, the domain is going to be when x is greater than 0. Okay? So x is greater than 0, that's in set notation, or we can write it as 0 to infinity. Okay? Now you might be thinking, but what about the negatives? I know you mentioned x can't be 0, but x could be negative 2. Well, let's think about that for a minute. X represents the ground speed. So can you have a negative value for ground speed? Can your speed be negative 40 miles per hour or negative 80 miles per hour? So although negative values make our equation defined in the context of this problem, it does not make sense. So we cannot include the negative values in our domain. All right. Next, it's asking us to use a graphing calculator to graph the function c of x for when x is between 0 and 1,000 inclusive, and for y is between 0 and 1,000 inclusive. So we want to graph our original function. So let's pull out our calculator again. Okay. And so now we're going to go to y equals, and we're going to enter in our equation, which is 150 plus ratio x divided by 8 plus ratio 8,000 divided by x. And I'm going to press enter to enter that in. And I now have restrictions on my window. So I'm going to go to window. And for my x, it said the minimum is 0 and the maximum is 1,000. And then for my y, my minimum is 0 and my maximum is 1,000. All right. And I'm going to press enter to select that in. Okay. So now once I have all that in there, I'm going to press graph so I can see what it looks. Ooh, pretty. Very nice graph. Awesome. So this would be the graph for C. Okay. So now we want to create a table with table start equaling 450. The change in the table 50, that means we want the table to go by 50, and then show the values for C of x for x values from 450 to 600. Let's go back to our calculator. So we're going to go to the table start. So we need to go to table, which is right above graph. So I'm going to press second graph to go to my table. So that's what my table, that's where I'm going to find all of my values. But I now need to set up my table. So table set is going to be above window. So I'm going to press second window to set up my table. So I'm going to make table start 450, because that's what the directions asked. And then I'm going to set my change to 50. And I'm going to press enter. I'm going to leave the independent and dependent for now on auto, which means the calculator will do the calculations for the specific x values. So I'm going to go back to my table. So I'll press second graph to go back to my table. And I see here that I now have my X values, 450, 500, 550, and 600 and then its corresponding Y coordinates. Now these Y coordinates are written as fractions, and I now want to convert them into decimals, okay? So to do that, I need to change a setting in my calculator. So I'm going to go to mode here, and I need my answers all the way down here to be put to decimals. I can always convert the decimal back to fraction if I like. So I'm going to move this all the way down here, and I'm going to set this to decimal and just enter. Okay, so that's set. And I'm now going to go to second table so that I can get my decimal values. Awesome. So on my notes, I'm going to write in the values for 450, 500, 550, and 600. Okay. All right, so we have 290, 288, 287, and 288.33. So, hey, so to the nearest 50 miles per hour, what ground speed minimizes the cost per passenger? Okay, so what ground speed, so what X minimizes the cost per passenger? So that's CM, which is your Y coordinate. Well, in looking at the table in D, I see here that as my X is increasing, my C of X or my Y is decreasing until it gets to 550, and then it increases again. So to the nearest 50 miles per hour, the ground speed that minimizes, or keyword minimum, minimizes the cost is 550 miles per hour. Okay, awesome. All right, that concludes section 1.2.